We continue with past papers, Biology 1400. Question number 1. Cellulose is important in human diets? Well, we need to know that cellulose is a very tough carbohydrate. Because of that, it is used as a dietary fiber. So, question 2. Which of the following statements about atomic structure is most accurate? The number of orbitals in each shell is always the same. This is not true. The first shell only has one s orbital. The second shell has got one s orbital and three p orbitals. So a second shell has got more orbitals than the first shell. So the first option is not true. Two electrons always occupy the s orbital of every shell. Really, is it true? Two electrons always occupy the s orbital of every shell. The s orbital can be occupied by two electrons maximum. Not always occupy. So two electrons always occupy the s orbital of every shell. Not always that two electrons are going to occupy. A maximum of two electrons can occupy the s orbital. Even one can occupy or none. Two p orbitals can accommodate a maximum of 4 electrons. Really not. The p orbital can accommodate a maximum of 6 electrons. Electrons in the outermost shell are called valence electrons. This was of course true. Each s orbit can only accommodate 2 electrons. This is not true. An s orbital can also accommodate 1 electron. It can accommodate a maximum of 2. The effect which helps to keep temperature fluctuations in water minimal is, so this is specific heat capacity. Specific heat capacity is the amount of heat energy that is required to raise the temperature of 1 kg of a substance by 1 degree Celsius. So when you have got water, for you just to change 1 kg of water, if it is at 25 degrees Celsius, for you to change the temperature to 26 degrees Celsius, it requires a very big or huge amount of energy. Because of that, when you supply energy to water, any amount of energy, the temperature will not be able to change until you exceed that amount of heat energy. That's when it will change by only 1 degree Celsius. So that is specific heat capacity. Which one of the following is false about phospholipids? They are signal mediators. That is true. They are amphipathic. That is true because they are both hydrophilic and hydrophobic. They hate water and love water. The heads love water. The tails hate water. They are components of bio and lipoproteins. That's also true. They play a role in the deposition of fats in the river. Deposition of fats, or this is more like why we have got some people who have got obesity. Are phospholipids involved in that process where they first get to accumulate in the liver? Necessarily not. They act as barriers to protect cell components. That's true because they are found in the cell membranes. So the option there which is not true is the one we both give next. Question 5. Which of the following substances do not dissolve in water? Ammonia can interact with water. Why? Because it has the nitrogen here has got a lone pair, and this can interact with water via hydrogen bonds. Sodium chloride can dissolve in water. Table salt does dissolve. Hydrocarbons can't dissolve in water because they are non-polar. Glucose does dissolve. Magnesium ion can interact with water, therefore that would be called dissolving. So numbers. Determine the valence electrons for an element whose atomic number is 11. So when something has got an atomic number of 11, the electron configuration is 2, 8, 1. Therefore, the valence electron in the outermost shell, we only have 1 electron there. That's option 5. Water has a high surface tension because, well, the reason as water having a high surface tension, this is what makes even insects to get to float on top of water. That is because of the greater strength of hydrogen bonds on the surface, and these hydrogen bonds are caused by cohesive forces between water molecules. So water molecules get to attract each other so much strongly that when an insect comes here, it will not break those cohesive forces between the water molecules. So that is option 3. Cohesive forces at the surface. That's the question 8. Fats and oils are chemically similar. Which one of the following about fats and oils is correct? Now, a fat and an oil, they are both lipids, but fats, they are solids at room temperature, whereas oils are liquids at room temperature. Again, liquids, because oils, because they are liquids, they are unsaturated hydrocarbons. They've got double bonds in them. The double bonds is what makes them being easily converted to liquids, whereas fats, which are solids at room temperature, are saturated. They don't have double bonds in them. So now let's consider fats and oils are liquids. Really not both of them are liquids at room temperature. Unlike fats, oils are made of polar fatty acids. Really not. Both fats and oils are made in the process called esterification. This is true. Fats are usually made of unsaturated. You've seen that's the opposite, so this is not true. Oils are usually from animal sources. Really not. Oils are mostly from plants. Fats are mostly from animals. So lipids, fats and oils both are lipids, and lipids are made in esterification when an alcohol gets to react with a carboxylic acid, forming an ester. And lipids are ester. Milk is made from, well, milk sugar. The sugar found in milk is lactose, and lactose is made from galactose and glucose. So that is option 4. The anomeric carbon in the furanose structure of fructose is the carbon number. When we're talking about furanose, a furanose ring is a 5-membered ring. Now an anomeric carbon is a carbon with a functional group. A carbon that contains the functional group in fructose is carbon number 2. It is only in glucose for carbohydrates, for monosaccharides and galactose, that we find anomeric carbon, the carbon function part. The structure below can be described as, we can see it as got, it makes like a pentagon, so that is going to be called furanose. If it made like an hexagon, this would have been called pyranose. And for us to be able to identify a ketone and an aldehyde, we don't look at this. We don't look at these structures. We look at the way the atoms are. If the functional group is at the, so we look at the linear formula, not on this one. Okay. So if the functional group is at the middle, that's a ketone. When the functional group is at the end of the chain, that is the carbonyl functional group, a carbon double bonded to oxygen, then this is an aldehyde. So we can't say it's an alpha ketone, an alpha aldehyde, or a beta aldehyde. And this is not a beta pyranose. It's not pyranose because it is looking like a pentagon, unless if it was looking like a hexagon. If a beta furanose is true, you look at the position of the OH to tell whether it's beta or alpha. When the OH is on top, that is beta. Question 12. Which of the following statement is false? Steroids are examples of lipids. This is a true statement. Lipids include steroids, cholesterol, phospholipids, fats, oils, glycerol, or those. Lipids are macromolecules. This is also true. They are really big molecules. Fat stores more energy than carbohydrates. This is also true. Saturated fats have several double bonds in their hydrocarbons. This isn't true. Whenever we hear of saturated means they've reacted with the maximum number of atoms they could have reacted with, and those don't have double bonds. Just like when you're talking about saturated hydrocarbons, it's only the unsaturated which don't have those. Sugars are more oxidized than oil, so that is true. So the answer here is option number what? Option number 4. This, what is the molecule below? The molecule is a, so when we look at this molecule, first part, these are 3 carbons which have reacted. We have got, this is a saturated hydrocarbon. This one, because there's a double bond, that's unsaturated. We have got a phosphate head. This is a phospholipid. Okay. Because it is a lipid having a phosphate head and then a tail. This is going to be non-polar, that's a tail. And then the head is polar, that's a phosphate. So that's a phospholipid. Let's consider question 14. Identify the correct description of hydrogen bond. Correct description of hydrogen bond. A bond between oxygen and hydrogen of the same water molecule. Same water molecule, when hydrogen and oxygen react, that's not hydrogen. That's a covalent bond. A bond between oxygen of water and nitrogen of another molecule like ammonia, that's not hydrogen bond. Hydrogen bond is between hydrogen of one compound with either nitrogen in another, oxygen in another, or fluorine in another. Okay. They shouldn't be the same compound. A bond between oxygen and hydrogen of different water molecules. This is true. A bond between 2 hydrogen atoms of different molecules. This is not true. 2 hydrogen atoms, a bond between them is a covalent bond, not hydrogen bond. Option 2 and 3, that's not true also. So the answer here is option number 3. Let's consider 15. A water molecule is said to be polar because